Notice I have not touched sign analysis today. Guys, my zeros, split these up, we'll do it fairly quickly. I see a 0 coming out, do not let me mess up here. I see a 5 coming out. Do this. And go out to 5. I got a 5. Got a 0. X intercepts. From my next factor, looks like if you solve it, we'll get negative 3 halves. Negative 1 and 1 half. Let's go over here. And you have another X intercept. Y intercept, of course, guys, is going to be 0, 0. And let's graph it. Now, when I jump into the graph, and someone remind me, this is odd. This is even. This is understood to be odd. What should be happening at 0, which came from here, when I get to it? Crosses, got it cross. That put it right here. The 5 came from x minus 5 squared to 2's even, should touch. X plus 2x plus 3, raised to the first, another odd should cross. Always make sure those things do happen as I get to it. Guys, I started on the left. I'm at negative 1 and 1 half, I think. And we're saying it should cross. And the end behavior, x to the 6th, we said the end behavior was over here, it's rising on both ends. So I can quickly say, Professor, I know it's doing this. And it's doing this. On both ends. Negative 1 and 1 half, it crosses. I can make it cross. And guys, if I make it, wait, negative 1 and 1 half was crossing out. It's going to cross, how far down cross? I don't know, but it's got to eventually come back. And pick up that next intercept. I'm at 0, I think 0 came from this, which came from an odd. The true, it's going to cross again. So it's going to cross, how far up it goes, I don't know, guys. Please tell me eventually it's got to come down, pick up that. Now, as it strikes or hits 5, does it automatically, in this case, bounce back? And we said at 5 it should just touch it and not cross over. And that's your graph. Done. Rough sketch. There's your graph. Finished in no time. First thing you guys work with this so much, you can almost see what the graph looks like in your mind even before you graph. You guys agree with this one? Okay. Okay. Now the last one, then we'll take a break here. Short thing. Anna, Bart, if you guys can add anything to it now while I'm doing this, before they reach calculus, let me know. Okay. I would love to show them, I'm sure you would too, how to find precisely that local min. I would love to show you. Somewhere in here there's a local max. I'd love to be able to show you exactly where, what's its value. We can't do it here. Oh, by the way, do I have another local min? But you could find the value. Is this right here another local min? Yes, it's 0. That one I know. It's 0, the y value, it's 0. Okay, guys, now let me jump in and get that last one done. Jonathan, since you're close by, watch carefully on this one, number 2 there. Do not let me make a mistake. And we'll get all this graphing finished up before the break. This will not slide. Okay, Jonathan? On this one, if I expand it out, be very careful. What does the first term look like? Up there, it's x to the 6th. On my second one, what does it look like? Be very careful. You multiply this mess out. It's negative what? I think it's going to be negative.
Negative x to 8.
I see 4, 7. I think I see 9. Do I see 9?
Oh, because of that x squared. Yeah.
Is it negative? Mr. Park, make sure when I finish this one up, you check it. Okay?
Okay.
Negative x to the 9 looks like it's the leading term I need to work with. Guys, by the way, is it 4? In fact, you're going to call it 4? Call me a negative 4x to the 9. Do you see a 4 there right here on the end in front? So I bet you multiply all this together, would you probably end up with a negative x, 4x to the 9th. Let's make it look better. Well, I have no effect on what I want to do, but at this point, does it look like that? Yeah. What do you think, guys? We multiply all this mess together, just look at the first term. That times that, raised to that, times that. Is it true? Okay. Now, the end behavior tells me right quickly, we got the first one out of the way up there. This end behavior says, find the limit. As you make x get large of a function, and on the other end, x is approaching negative infinity of this. The guys go to this, let's hope this is correct, replace x by some large number, but be careful. You raise that number to the 9th power, which makes it get larger, but then multiply by what?
4.
Negative 4.
Negative 4.
Don't forget that negative. So what? All that going to turn that into negative infinity. That's the one Parker's going to watch when I finish it up. The next one says now you're approaching negative infinity. Some negative number being replaced. If I put some negative number in here, raise it to the 9th power, guys. The negative raised to the 9th power doesn't remain negative. Then times the negative 4 out front turns it into a, interesting. Be careful on that. But each one catch me here if I make a mistake. Okay, guys, let's sketch it fairly quickly. The intercepts are, help me out, 0, 3, is that true?
Negative 3.
Negative 3, okay, 0, negative 3.
And then can we do a difference of squares on 4x?
Beautiful, hang on just a second. Beautiful, beautiful,
Is
beautiful.
it a sum of squares?
You know 4x squared plus 1 will not factor. 4x squared minus 1, that's the difference of squares. No, even if I try, look at this. If I try and say, wait, Professor, what are you going to do here? I said equals 0, no problem. But what's going to happen, guys, if I move that 1 over, I think you end up with negative 1, and then divide by 4, and I'm going to end up with a square root of a negative, which takes me into imaginaries. And I can't deal with them on the grid. So work those on the end. Okay, I got my 2, zeros, x-intercept. Y-intercept, guys, not going to be interested here. In this case, is 0 again. Okay, let's get the end behavior. Out on the right, positive infinity, where x is. And my x on the x-axis, out here, that's furthest to the right, my graph goes. And it should be dropping from there. Oh boy, interesting. Out on the other end, we're approaching negative infinity on the left. And the furthest to the left, my graph right now goes is negative 3. And we decide after that, it does what for the end behavior? It goes up. Positive infinity. Interesting, interesting. Now, see the cross touch, guys, at, thank God, where am I? Yeah, back up here. I'm gonna get a 0 here, and that came from x to the 4th. Is that true? What happens because of that 4 there? It touches. So that means it's going to touch here, and where was it? At 0, oh, 0, it's going to touch. At negative 3, which comes from this, I think, it crosses because of 3, odd, on the outside says odd, it's going to cross. And then this one, of course, we can't do anything with it. Okay, I don't think we, no, I'm back, did I say cross somewhere? Oh, that's up there on that one. Okay, here goes, guys. Geez, keep track here. Let me get that negative 3 out of the way. Did we say it's going to cross there? I think we did. It's going to cross over. How far down it goes, Jonathan? I don't know. It's got to come back. It's got to pick up 0. And if we describe as 0, does it just touch it? And sure enough, that makes it bounce back, and it does just touch. Park, is that pretty close?
Yeah. It is. We were debating, and then we found out it was power cube. So you're correct.
So mine looks pretty good.
Yeah, yeah. Right? It's power.
It
should be power cube.
Cube?
If you were to ask us about the all zeros and we had to simplify the 4x squared, it's I 1 over 2. Right?
Whoa, look at that.
Plus or
Look.
minus I 1 over 2. Is
Hold on, Mr. Mathematician, here we go. If I say find the zeros, like I did on that test, let's return you guys, test number 2. One of those questions says find the zeros. If you look at your papers, these students just give me the real. If they say find the zeros, they want all of them. And also sometimes they'll use the word complex, find the complex zeros. Okay, so if they just say find the zeros, they want all, imaginary and everything else. If they say find the real zeros, they just want the real numbers, no eyes. This one though, here we go, Eric. I'm gonna start listing these. If you split this up, that up, quickly I see a 0 coming out here. So 0, one of the answers. Is that true? By the way, multiplicity, let's get the multiplicity out of the way. I've got 0 here, guys. Looks like it came from this. Multiplicity of 4. It's like 0, 0, 0, 0. Okay, multiplicity 4. The -3 came from here. On the outside was a 3, indicating that -3 also has a multiplicity of 3. Now, I'm gonna go ahead and include the imaginaries. 4x squared plus 1, I tried it right here. To finish it up, you're taking the square root, so x is equal to plus minus. Guys, what's the best way to express square root -1/4?
I 1/2.
Here we go.
Plus or minus.
Plus or minus 1/2 I? I/2? Or that? Is this what guys? Is it plus or minus 1/2 I? So if I say find all of them, you still got this, 1/2 I, -1/2 I. If I say list all the zeros. That's true? Now, let's count. We got 4, 3, that's 7, 8, 9. And what did we say the degree was back here somewhere?
9.
It was 9, I think it was 9 here somewhere, all this work I'm doing here. I think it was a 9 there to work with. Which we should have 9 zeros. Now let's just slow down and see what you guys have been saying. Parker, you're saying this looks pretty good?
Yes.
Leo?
It was just clear, every year, like, square root the -1/4. Did you also look at it as like square root -1 to get the I, and then just square root 1 and then square root over square root?
Absolutely, and then over square root 1, square root 4.
Yeah.
That'll lead you to what, plus or minus 1/2 I. Okay, anything else? Pretty good lesson. I thought it was beautiful. We'll recap and then you right into some sketching. Yes?
My question is on the 4x squared plus 1 on the second one that we just did. We're not counting the degree because it's on the outside of that parenthesis because it technically is in the inside, right?
Exactly.
Okay, just making
Are you talking about the one that stood be out there?
Yeah, exactly, yeah.
Now, what I'm trying to make you visualize, Eric, not Eric, John. If you were to multiply all this mess out, I mean, actually expand it out. I'm just asking, what would the first term look like? They're always concerned about the first term.
Okay.
Would it be what we said it was, a -4x to the 9th? If you multiply all this mess, that mess out, would you expect the first term to be a -4x to the 9th?
Yeah.
And that's what determines that end behavior.
Okay.
Make sense?
Yeah, I mean, I was concerned about the last, the parentheses, but I.
Oh, I got you, guys just being raised to the first.
Yeah.
Yeah, okay. Got anything else? Yeah, it's almost time for the break. I'm not doing anything else. But, before we get in the handout and get back in the break, get ready. Get ready. After the break, you will be doing this, you and I together. X to the 5th, subtract 7x to the 4th, plus 19x cubed, minus 37x squared, plus 60x, subtract 36. Should all this copy down correctly. Just copy down correctly.
Yep.
Okay. Now, would anyone like to complete the course as of today, and I'll post your aid for you? And you don't have to come back. I'll go ahead and post your grade. Tell SMC, they're done. The question would be, could you, within a minute, tell me how many zeros am I expecting with that thing?
5.
Got, anyone, tell me right quickly, the 5 zeros.
Because of the.
Oh, I said just recent. Anyone know the 5 zeros? If so, you're finished with the course.
No, you're talking about using paper on this.
Oh, I'm not talking about anything yet, until we get to that handout. No, I just want to, does anyone know the 5 zeros? There should be 5 zeros, 5 answers.
Tell you the liner stuff.
Oh, geez, negative 36 is a lie just there. 5 zeros. Everyone's gonna be with me. You got, what, 3 more weeks after this? Yeah, you're gonna be with me for the main term. Now, when you get back from the break, guess what we're gonna do? We're gonna find the 5 zeros. We're gonna actually find them. Right now, if I was you, I'd say, oh, there's no way, because how on earth could that long, drawn-out polynomial, how can I find the 5 zeros? And that's where that handout's going on. Guys, take your well-deserved, I think 15 minutes, 15-minute break.